Hello and welcome to the first lesson of the school year on section 1.1 Variables and Expressions. As you go through this, remember it's okay to pause the video in order to take notes because I might move faster than the speed you're writing. So pause, rewind, and write down everything you can. So here we go, a couple of definitions. A quantity is anything that can be measured or counted, and a variable is a symbol, usually a letter, that represents an unknown quantity or value. A numerical expression is a mathematical sentence that contains numbers and operations with no variables. For example, 4 plus 2 or 7 minus 3. And an algebraic expression is the same thing as a numerical expression, but it includes variables. So x plus 3, n divided by 5, s minus 14. Those are all algebraic expressions. Addition and subtraction. So what is an algebraic expression for the word phrase? 32 more than a number n. Well, we have n amount, and it's 32 more than that. So it's n plus 32. 58 less a number n means take away n from 58. So it's 58 minus n. And so now I want you to try these two on your own. So pause the video and take 15, 20 seconds to do these two, or more time if you need, and then we'll go over them. So this first one is 15 more than a number x. So it's 15 more than x, so it's x plus 15. And then the second one is y less than 29. So it's 29 minus the quantity y. Multiplication division. So 8 times a number n means you have 8n. So you could write it as 8 times n in any three of these expressions. And then the quotient of a number n and 5. With division, the order that the variable and the number come in matters. The first number goes on the numerator, and the second number always goes on the denominator. So in this case, the first number is a variable. So n always is the numerator, or the first term, and 5 is the second term. 7 times a number g. Try these two on your own. So this one is 7g. We could write it as 7 times g, or you could write it as 7 times g in any three of these forms. Then the quotient of 12 and a number n is 12 divided by n, or you can write it as 12 over n. And then writing expressions with two operations. So here are 3 more examples. So 3 more than twice a number x is 3 plus 2x. 9 less than, so since it's 9 less than, you're subtracting 9. The quotient of 6 in a number x. And remember, when we see quotient, that means division. And so 6 comes on the numerator, x is on the denominator. And then the product of 4 and the sum of a number x and 7. So since it's the sum of a number x and 7, you have to put those in parentheses because it's the product of 4 and the sum. So it's 4 and the sum. Well, what's the sum? The sum is of a number x and 7. So it's whatever that sum is times 4. So there's parentheses because you have to do order of operations. So try the got it part right here. What is an algebraic expression for each word phrase? 8 less than the product of a number x and 4, twice the sum of a number x and 8, and the quotient of 5 and the sum of 12 and a number x. The first one is going to be written as 4x, because that's the product of a number x and 4, an 8 less than that product, so you're taking away 8. B is a little trickier. It says twice the sum of a number x and 8. So it's 2 times the sum. And so the sum is x plus 8, and it's twice that, so it's 2 times that sum. And finally, the last one is the quotient of 5 and the sum of 12 and a number x. So since it's quotient, you know it's going to be a division problem. And the first number is always your numerator, so 5 is my numerator. And the second term is your denominator. And my second term is the sum of 12 and a number x. So it's 12 plus x. Sometimes we have to do the opposite and write a phrase for an algebraic expression. So it says write a word phrase. What word phrase can you use to represent the algebraic expression 3x? And there's many answers to this. It's not just one. You could do 3 times the quantity x. You could do 3 times a number x, or the product of 3 and a number x. And so down here it says what word phrase can you use to represent the algebraic expression? I want you to try these 4 right now. So to save time, I'm not going to write out all 4 of them, but I'll tell you how I would write them out. This first one I would write as the sum of a number x and 8.1. For letter B, I would write 10 times a number x plus 9. You could write plus, that's okay. For number C, you could write the quotient of a number n and 3. And for letter D, I would write 1 less than the product of 5 and a quantity x. Remember, there's multiple answers to these, so there's not just one correct answer. There's many ways to write these out. So here's our last question. It's a word problem. It says, write a rule that describes this pattern. So it says, the table below shows how the height above the floor of a house of cards depends on the number of levels. What is the rule for the height? Give the rule in words as an algebraic expression. So try that on your own. Here's the table that shows you the pattern. And so notice that 2 connected to that 2, 3, 3, 4, and 4. So if you see the pattern, if we have n number of levels, it's going to be written as 3.5 times n plus 24. Notice it's plus 24 because 24 is the given height of your table. That's not going to change. The height of your table is always going to stay the same. So you're always adding 24 to the height of the cards. But each card is 3.5, so the number of levels you choose with the cards, you have to multiply by 3.5. So if you only have 1 level, it's 3.5 times 1. If you only have 2 levels, it's another 3.5. The third level is another 3.5. The next level is another 3.5. So you can do 3.5 times plus 3.5 plus 3.5 plus 3.5, or 3.5 times 4, or in this case, when it's n, it's 3.5 times n, the number of levels.